Hello, welcome to Block 2, Use of Algebraic Notation, Lesson 11. I'll share my screen. So, in your previous lesson, you learned how to substitute values into two-step expressions. In today's lesson, you're going to learn how to generate sequences from algebraic rule. But before we start, I would like you to pause the video and do these retrieval questions in 4 minutes. You can take longer, you can work at your own pace. Okay. Assuming you paused the video and you worked at your own pace and you've really thought about what you were doing, take note that this retrieval practice covers quite a few of the topics that have been covered in previous lessons. So here are the answers. So for the first one, you were asked to find the next two terms in the sequences. So to find the next two terms in the sequences, here you can see that we're simply adding 4. So here 15, you just need to add 4, and then to get to the next one, you just need to add 4. Here you can clearly see that we're multiplying by 3. Okay, so if you multiply 2 by 3, you get 6, 6 by 3, you get 18, and so you can do the same to get the other terms of that sequence in 1b. In 1c, it is clear that we are halving. So each time you halve the previous term to get the next one. And then you're being asked which of the sequences in question 1 is linear. It is obviously question 1a. Why? Remember what we learned? A linear sequence has a constant difference. And you can clearly see that 4 is being added every time. So it's a constant difference of 4. And then here you were asked to substitute n equals to 3 into the expression 10 minus n in brackets to the power 2. Of course, if you do 10 minus 3, of course, you know you have to do that first because the expression is in a bracket. Before you square it, your answer will be 49 because 10 minus 3 is 7. 7 squared means 7 times 7. That will give you 49. And then you're being asked what mistake have led to the other answers, which I'm just going to look at the one and then you can think about the others. So for this one, the person, to get 1, the person may have done 3 squared first. Okay, so that would give them 10 minus 9, which is 1 before squaring 1. Okay, so that's one of the mistakes that would have been done. Okay, let's move on. Okay, initially, in your first lessons, in your previous lessons, you were able to generate sequences using numeric rule. So you were told, okay, here is the first term of the sequence. We're going to be adding 7 every time. And that was fairly straightforward and easy. Okay. And then all you did was just to, keep adding 7, 7, and then that gave you the sequences. But we're going to build on that learning and move things forward. Okay. Because you're getting better and better at maths. We're going to use what we call algebraic rule. So this same sequence could be generated from a table could be generated in a table using this algebraic rule, which is 7n plus 1. How does it work? We're going to have n, and then the position if we're looking for the number, that the value of term 1, that is position 1, and that's what we're going to substitute in to replace n. So remember, you can see now that the skill from your previous lesson is useful, which is to substitute values into two-step expressions. Okay, so for position 1, we'll simply say 7 times 1 plus 1, because remember 7n from your very first rule. Remember your very first lessons, you know that 7n means 7 times n. Okay, don't forget these rules of algebra. So you now say 7 times 1 plus 1. To get the next one, you do 7 times 2 plus 1. Okay, to get the next one, you do 7 times 3 plus 1. To get the next one, you do 7 times 4 plus 1. And to get the next one, you do 7 times 5 plus 1. Okay, I want you to have a think. How would we do this one? How would we do this one? If we wanted to find the value of the term in the first position, value of term 1 in the sequence, okay? Of course, I'm sure you're thinking the way I'm thinking right now, because remember from our previous lessons, we learned that whatever is in the bracket, we're going to do it first. So we're going to do 1 plus 1 before we multiply it by 7, because the 7 outside the bracket is multiplying this term. Okay, it's multiplying the expression in the bracket, sorry, which is n plus 1. So that will be 1 plus 1 times 7. To get the next one, it will be 2 plus 1 times 7. To get the next one, it will be 3 plus 1 times 7. To get the next one, 4 plus 1 times 7. To get the next one, it will be 5 plus 1 times 7. Okay? I'm sure you haven't forgotten these rules or these what you learned on how to do substitution. Okay, so what we've learned so far is yes, we can use numeric rule, which you learned in your very first lessons, to do substitution, or sorry, to find the next terms of sequence. But this time we are moving forward. We're making progress. We're now using algebraic rule to generate the terms of a sequence. Okay, and a lot of the algebraic rules you will see will be written as a number n plus something, or a number n minus something. So I would like you to have a go at questions 1, 2, 3. Here is question 1. You can pause the video and do question 1 in 3 minutes. Assuming you've paused the video and you've worked through question 1, here are the answers. Let's discuss them. So for this one, you're told that n is 3. You just need to substitute. So here you're told find the first 3 terms of these sequences by substituting n equals 1, n equals 2, and n equals 3. So when n is 1, this will simply be 4 times 1, okay? When n is 1, it will be 4 times 1, and then when n is 2, it will be 4 times 2. When n is 3, it will be 4 times 3, okay? And then here, when n is 1, it will be 2 times 1 plus 3. That will be 5. When n is 2, it will be 2 times 2 plus 3. So 2 times 2 is 4. Remember, 2n is 2 times n. Don't forget, the very first things you learned in algebra, when a letter is next to a number, we simply multiply both of them. But this time, because you were substituting n with a number, it's going to be 2 times that number. So when n is 3, it's going to be 2 times 3 plus 3. That will be 9. And for the other one, you do the same thing, and those will be the answers. Okay, here is question 2. I want you to pause the video and do question 2 in 3 minutes. Again, you're asked to substitute n equals 1, n equals 2, and n equals 3 all the way to n equals 5 into each of these expressions. So another way to put this question, I could have asked you to find the first 5 terms of this sequence. So I'll just give you 5n. Say find the first 5 terms. Of course, you would do the same thing that we're doing now, but it's just put very simply to you to use the values of n1 to 5. It's the same thing as telling you to find the first 5 terms of a sequence. Okay. Now, assuming you've paused the video and you've really thought about these questions and you've worked through them, so here are the answers. So here are the answers. And then the question, the last bit was, what do you notice about your answers? What is the same? What is different? Now, all go up in fives from a different starting number. Okay, so all of them go up in fives from a different starting number. Okay, that's what we notice. Okay, here is question 3. You can pause question 3, pause the video and answer question 3 in 5 minutes. Okay, or you can work at your own pace. You can take longer. So the question is, find the first 5 terms of the sequences given by these rules. Okay, so these are all algebraic rules. Now, assuming you've paused the video and you've worked through it, you've really thought about this problem, here are the answers. Okay. So here, to get this one, I'll just demonstrate the first terms of all of them. You simply do 6 times 1, which is 6, minus 10 is negative 4, right? This one, you do 7 plus 3 times 1. So 3 times 1 is 3. 7 plus 3 will be 10. Okay. This one, we do 0.5 times 1. Okay. In this case, because it's our first position, so that will be 0.5. Anything times 1 is that thing. So it's now 0.5 minus 1 will be minus 0.5. Here, 2.3 plus 4n. 4n, n in this case, in the first position will be 1. So it will be 2.3 plus 4 times 1. So it will be 4 times 1 is 4. So it will be 2.3 plus 4. That will be 6.3. This one, sorry. This one will be 1 plus 5, which is 6 divided by 4. 6 divided by 4 is 1.5. This one will be 1 over 4, which is a quarter. A quarter is 0.25. 0.25 plus 5 will be 5.25. Okay. And then you can discuss with, your partner or your parents or, and your friend whom you're watching this video with or whom you happen to discuss this video with. About how you worked out your answers. You worked out your answers by using the algebraic rules and using your skill of substitution, which you learned in the previous lesson. Okay, so you can see how everything links up. Okay, so here is something for you to think about. So here, I want you to find the first 5 terms of the sequence given by these rules. What do you notice? What do you notice? Okay, I'm going to assume you've paused, you've worked through it, and you actually notice that this one is increasing, right? Because we're adding 3. We're adding 3n. So as we keep multiplying 3 by the terms of the sequence as they increase, of course, we're going to be increasing the sequence. Why this one we're subtracting, so we have a decreasing sequence. So you're going to hear these words: ascending sequence and descending sequence. Ascending means going from low to high. So you can see going from 43 to 55. Descending means going from high to low. So the sequence is descending. But here is something. Does it mean that we will always have? So if we have an algebraic rule where we're subtracting a number, does it mean it's always going to be a descending sequence? Because that's what Mo says here. Expressions with a subtraction symbol will always generate descending sequences. Is it true? Really? Really? Have a think and see whether you come up with something that disproves Mo's argument or thinking. Of course, Mo is incorrect, because if we do x squared, x to the power of 2 minus 1, we're not going to create a descending sequence. Even though we're subtracting 1, we're going to create an ascending sequence, because if we take the term 1, yeah, if we want to find term 1, we'll say, okay, 1 squared is 1. So 1 to the power 2 is 1, because 1 squared means 1 times 1. 1 minus 1 is 0. But look out, when we go to position 2, we'll say 2 squared is 4. So 2 squared means 2 times 2. 4 minus 1 is 3. And then when we do 3, it will be 3 squared minus 1, which is 9 minus 1. 4 squared, which is 16 minus 1. You can see we're creating an ascending sequence, even though we have a subtraction symbol in the expression. Excuse me. Okay, what have we learned so far? So we have learned that you can have an ascending sequence and a descending sequence. And it is not all the time that you have a subtraction symbol that you're going to have a descending sequence. Doesn't mean you're always going to have a descending sequence. And we also learned that when you're working when you're working these out, it's important that you think about the rules, the algebraic rule that is generating the sequence. You really need to think about what's going on. Okay, I would like you to have a go at question 4 to 6. Okay, I would like you to pause the video and work through question 4 to 6 for 6 minutes. Okay, assuming you've paused the video and you've worked through question 4 to 6, you've really thought about the questions and you've worked through them, really well. Here are the answers. So we'll discuss the answers. For question 4, you asked, find the first 4 terms of the sequence given by these rules. So here we have 20 minus 2n, right? So 20 minus 2n means to get the first term, we'll do 20 minus 2 times 1. And that will be 20 minus 2. 20 minus 2 times 2. So to get this one, so that will be 20 minus 4. Okay, so on and so forth. Then this one is 1 minus 4 times 1 to get the first position. 1 minus 4 times 1 is 4 times 1 is 4. So 1 minus 4 is negative 3. Then 1 minus 4 times 2. So 4 times 2 is 8. 1 minus 8 is negative 7. So on and so forth. That's how we generated that one. And then question 5, you ask, which of these rules do you think will produce ascending sequences, which will produce descending sequences? Label the cards. Okay. You can find this out by actually working through them to check which will give you ascending and descending sequences. Okay. And then how did you decide? Okay. So when the n term is positive, it is ascending. So Okay, that's how you decide. So when you see the n term is positive, so that's not positive, so it's descending. That's positive, even though it's written the other way around. We could have written this as 3n minus 9. That's not positive, so it's going to be descending. Okay, all right. Here is the answer to question 6. Question 6, you were being asked, tick the rules that will produce linear sequences. Okay, the rules that will produce linear sequences, you work through them by thinking of, doing some substitution and finding out whether each of the terms you have a constant difference. But I want you to hold on to this thought, because there is another way to figure out which of these will give you linear sequences. There's another way. So just have this at the back of your mind, because we'll come across this again, okay, in our next lesson, how we actually look at something and say, oh, that's linear, that's non-linear. Okay. All right. What if I give you a question? I give you an algebraic rule and I say, find the 1000th term, okay? Or find the 50th term. How would we do this? Yeah? What do you think? How would we do this? I think you're beginning to see how this algebraic rule is very useful and why your skill of substitution is very useful. Because if you were to use the numeric rule that we're using, let's say I gave you a number the first term and I say the numeric rule is to add 6 every time, and I say find the 50th term, I'm sure you'll be very angry and upset. Why would Mr. Otero give me such work? Sit here adding 7 until I get to the 50th or 100th term. Well, there is a much clever way to do it. If we have an algebraic rule, which is 12n minus 9, all we have to do is to substitute 50, because remember, with the algebraic rule, we can find any term of the sequence by just substituting that term, replacing n with that term, yeah, with the position of that term, yeah. So if we want the 100 term, we'll simply say 12 times 100 minus 9. But this time we want the 50th term, so we'll simply say 12 times 50 minus 9, and that will give us 591. Okay, really interesting. Okay, I would like you to have a go at the rest of the questions. So what have we learned so far? We've learned that you can find the term of a sequence far out. Yeah, if you're given the algebraic rule, you can simply substitute the term you're looking for, the position of the term you're looking for, into the algebraic rule, and you just use your substitution skill, which you learned and you're still using in your previous lesson and you're still using in this lesson. Okay, so pause the video and have a go at questions 7 and 8 for 4 minutes. Assuming you've paused the video, of course, you can take longer. You can work at your own pace. Here are the answers. Okay, so you will ask, here is a rule for a sequence. In which position would the term 2 be? The term will be in the third term. So you could have done simple substitution to find out the values of the terms, and then you figure out that term 2 will be the third term. The term 2 will be the third term. Okay, what would the 50th term of the sequence be? Okay, you just do your substitution. So 4 times 50 is 200. 200 minus 10 will be 190. And then would the number 77 be in this sequence? Explain how you would know. No, all the terms would be even. Okay, all the terms would be even. So 77 would not be in the sequence. And you can notice that by finding out the first term, second term, third term of sequence, you will see a pattern, and then you can clearly see that all the terms are even. So you're not going to get 77. And then D, question 7D, Would the number 68 be in the sequence? Explain how you'd know. No, 68 would not be in the sequence. How would we know? Okay. Now remember, we can use inverse operation. If you remember, right? So if we have 4n minus 10, okay, and we say we're getting 68, okay, so we're trying to check, would the number 68 be in the sequence? Of course, if we say if 68 is going to be in the sequence, it means going backwards, okay? Remember, going backwards, we want to check whether things would work because that's how you check. We will do 68 add 10, okay, which will be 78, right? Now, if we're going backwards, remember when we were doing function machines, that means 4 times n. It means going that way, we need to divide by 4, okay? So we're not going to be able to divide 78 by 4 because 78 is not a multiple of 4. We're not going to be able, yeah? So when we do this, we'll see that it's not going to work because we should really get a whole number when we finish, yeah? So that's how we demonstrate that. Okay. Let's move on to question 8. So question 8, here is the answer. Question 8, you asked, here is an expression for a sequence 77n minus 96. What is the difference between the 1000 term and the 990th term? Of course, you can do simple substitution. Okay, you do the 1000 term will be 77, that will be 77,000 minus 96. You work that out. Then that will be 77 times 990. You work that out. Yeah. Times 77 times 990 and then minus 96. And then when you finish, you work out the difference. And then here you're told write 2 more terms that will have the same difference. Of course, you can write many more terms, but have you noticed that when you do that, it's always terms that have a difference of 10. So every terms that are 10 apart will give you this. Okay. So you could do 1010 and then 1020, you'll get the same. So when they're 10 apart, you'll get the same result. Okay, that brings us to the end of our lesson. So what have we learned so far? In this lesson, we have learned that before now, you have been using, you can use simple numeric rule to generate the terms of a sequence. But in this lesson, you have learned that you can use algebraic rule to generate the terms of a sequence. So first, the simple aspect is you can just generate the first 5 terms of the sequence using the skill of substitution, okay, which you learned in the previous lesson. And then you can even make progress to generate terms that are far out, okay? So you can generate, for example, 50th term, 100th term, okay, by simply using your rule of substitution to find out the values of the terms of this sequence. Okay, until next time, bye-bye, take care.